Okay, here comes a little video on feasible regions and minimums and maximums. This is called objective functions, also known as linear programming. So what we're going to do today is we're going to split this up into two separate videos. I'm going to tell you right now, this video is only going to cover how we do linear programming. And then I'm going to need you to watch part 2 video, which is going to take us through a linear programming problem from start to finish as an application word problem. So this is just the skills. Make sure you watch part 2 video, which takes you through an application problem. Okay? So the first thing you've got to look at is the type of graph when you're done. You know how to graph inequalities, and we shade. And this is our feasible region, the shaded in part. Now remember, the way we taught you, you leave your answer unshaded. But the intersection points of your graph are going to be very important, and we're going to need those intersection points. So, when we have a region that is totally bounded on all sides, that is known as a bounded feasible region, and we are going to have a max and a min. So what we have to do is we just take our 4 intersection points and we substitute them into our objective function, which is the c equals 3x plus 5y. So this is going to give us 3 times 2 plus 5 times 3, and that's going to give us 21. We're going to substitute in the 6 and the 0, so 3 times 6 plus 0 is 18. Let's substitute in negative 1 and 2. So 3 times a negative 1 plus 5 times 2 is going to give us 7. And then the last one is negative 2, negative 1. So that's 3 times a negative 2 plus 5 times a negative 1, which is going to give us negative 11. So then you have to state your max and your min, because this is a bounded feasible region. So our maximum is 21. And our minimum is negative 11. Okay, and that's all you have to do is list the values that your max and min are, and you'll have to show your work of where you got your max and min. Okay, so number 2, I'm going to step you through, and I want you to try this one on your own because this takes us to a different topic. Notice how there is no solid line or dashed line here that's stopping this. This is known as unbounded, which means this is going to go on forever in this direction. So, since it's going to go on forever, you can only have a max or a min. You are not going to have both. And I will show you how to get those. So, of course, this time we only have 2 to substitute in. So, we have a 0 plus 5 times 2, which is 10. And in this one, we have a 1 plus 5 times a negative 1. And that's going to give us negative 4. So the question is 10 our max, or is negative 4 our minimum? You are only allowed to have 1 for an unbounded region. To do that, you plot a test point. So you test a point somewhere that's in that region. So let's pretend we're substituting in the coordinate 10, 0. If we substitute 10, 0, we're going to get 10 plus 5 times 0, which is 10. So it's equal to this. Let's try another one. Let's try maybe 15, 2. We can see that's going to be in there. So let's try 15, 2. That's going to be 15 plus 5 times 2, which is 25. Notice how our test points are not getting any smaller. And if we were to continue coming out this way, it would just get bigger and bigger and bigger. That means there's going to be no maximum, which means we have a minimum of negative 4. We do not have a maximum. Okay, but all you have to do is plot the test point. If we were to plot 20, something, that would give us an even bigger number, and it would just continue to grow and grow. Okay, so that's how you find a max or a min. So this is just a straight up objective function problem where you're going to have to graph all three of those lines, find the intersections all by yourself, and then go find a max and a min, or if it's unbounded, just max or a min. And then we will get to a word problem in the next video. So the first thing you want to do is graph all three. So x is greater than or equal to -2. So we're going to go to -2. This is an x, so we have a vertical line, solid. This is x is greater than or equal to. Remember, in this class, for the purpose of how intense this might be, we are going to shade false. So we are going to shade to the left, even though it's greater. Okay, so we're going to shade this way. Then you're going to graph your next line, which is y is greater than or equal to -1. So we're going to do our horizontal line at y equals -1. It's greater than, so we are going to shade false, meaning we are going to shade below. And then finally, our last line that we need to graph is x plus y is less than or equal to 4. So that means we have an intercept at y is 4 and x is 4. And you're going to want to continue that slope. You can see that the slope is -1. You could also rearrange this and make it y is less than or equal to -x plus 4. And I always suggest doing a few points in each direction because you really want to get some nice points. So this one, we're going to have our horizontal line that looks like this. And this says y is less than, so since we are going less, that means we would like to shade false and shade above. So we have three very important points. Those important points are the intersections of the three lines that we graphed. You do not need the axes in any way. You only find the intersections of your region. Now again, notice how we have, see how much easier it is to see when you're doing all of that. We can see that it's going to be inside. So we have a bounded region, so we are going to have a max and a min. So we need to take those three intersection points that we just found. So we have -2, -1. We have a -2, 6. And we have a 5, -1. And what we're going to do is we are going to substitute each one of those individually into our objective function, which is 2x minus 3y. Okay, so that's going to give us 2 times a -2 minus 3 times a -1. So -4 plus 3 is a -1. We're going to substitute this one in as well. 2 times a -2 minus 3 times 6, which is equal to -4, and a -18 is a -22. And finally, 2 times 5 minus 3 times a -1 is going to give us 10 plus 3, which is 13. So we have a max of 13 and a minimum of a -1. Okay, now this video is going to continue on a part 2 because these are just the skills you need to be able to do an application linear programming problem. Okay, so this is Longo and I'm only kind of out this time. You need to go watch the second part to this video. Okay, see you in a few. Bye-bye.